Hello, everyone, and welcome to, I think, our third iteration of Global AI London. I have a really brief introduction, and then I will get to our main event. A quick overview of our session today. It's going to be a short one, so 6 to 6:35. I'll do a real quick announcements, and then I will pass you to Andre. So my two announcements are, if you wanted to follow us along, join into our next sessions. We do a mix of remote and in-person sessions, and we tend to run our remote streams maybe once every other month. So if you're interested, the best way to sort of stay in touch is via Meetup. You should be able to scan the QR code and get access to our Meetup and sign up there. Alternatively, we tend to stream only to this channel, so follow along as well, and you'll be able to see our new streams. And then our second announcement, which is more exciting, is that we are coming back with the Global AI Bootcamp again this year, and this is our first time that we're running it in person as well. So if you are in the area, if you are near Paddington, you can sign up again on our Meetup page, but on the 6th of March, we will be running an all-day session, and we've got about 10 speakers for you, so I'm really excited for that one. So without further ado, I will introduce our speaker. Hello.
How are you?
Hi, how are you?
I'm good. Excited to be here.
I will just pull up your slides and let you go. So before I send you on, if anyone's got any questions, please put them in the chat and we can go through those at the end of the session. Awesome. I will see myself out then. Thank you very much.
Thank you. All right. So hi, everyone. My name is Andre, and I work as a product manager in Azure API management team. And today I wanted to share with you the pattern that we see comes up in a lot of customer conversations with developers, especially, which is called the AI gateway pattern. And I also will share what it means from an API management perspective and what we actually build to help developers build AI gateways within their organizations. So first of all, like, why API management and GenAI? Like, what is happening? Like, why do we even talk about GenAI if we're an API management solution? Well, if you interacted with large language models, for example, as OpenAI, you know that you have an endpoint, you have an API key that you append to your request. You send API requests with prompts, you receive API responses with completions. So that's essentially an API, right? That's just yet another API. You have an endpoint, you have an API key, you interact with just like regular API. And like any other API, these APIs must be managed, secured, and governed. However, with LLM APIs or AI APIs, there are specific challenges. Probably all of you know that when you send prompt or you receive a completion, you consume tokens, and tokens is the main currency when it comes to large language models. When you receive or send prompts, you essentially spend tokens, and that leads to unpredictable costs because you might have multiple developers calling the same endpoint. You don't really have a lot of way to control the cost and also understand how many tokens were consumed by each team. So that's something which is not available in like traditional API management solutions. Then there are reliability concerns. What we see customers doing, they first start with POCs. They're trying to understand the best use cases for large language models. But then once they understand the use case, they don't want to use just regular pay-as-you-go endpoint anymore. What they're doing instead is they're purchasing what is called, especially when it comes to Azure OpenAI, they purchase in what is called provision throughput units, or PTUs. And you can think about PTUs as a reserved capacity for your workload, but then even that can throttle, even that can go over the tokens per minute limit. So what customers want to do is they want to have a load balancing between multiple endpoints. They want to have PTU as a kind of a first priority endpoint and then fail over to pay as you go. So how do I do that with API management solution? Then there are security risks, right? There is a key that is tied to a specific endpoint, which can be used with multiple deployments. Like, I don't really want to share this key with everyone in my organization, especially if I have like tens of different teams. I want to have something better than that. I want to have some different authentication mechanism. And then there are general challenges when it comes to these APIs, like how can I improve latency? How can I make sure that they're reliable? How can I make sure that my developers can easily discover those APIs to consume? And a lot of these challenges, as I mentioned, they already kind of solved with API management. So we provide high reliability. You can have multiple scale units. We have developer portal to make sure that those APIs are discoverable. We have security mechanisms with different managed and unmanaged ways to authenticate to endpoints and also authenticate API consumers. But that was not enough. There are specific challenges, especially in the token-based area, I would say. So that's why we introduced GenAI gateway capabilities in Azure API Management, which are essentially, you can think about it as a set of features tailored specifically to AI APIs. So what are these features? So first one is Azure OpenAI token metric policy. And this is the policy that allows you to track token consumption across multiple developers, multiple teams. So we integrated with application insights. And with this policy, what you can do now is you can send token count per a specific dimension. And this dimension can be a subscription ID, it can be user ID, it can be IP address, and can be pretty much anything else that you can think of. For example, if you agree within the organization that a specific team sends a header with a cost center number, that's also something that you can use as a dimension. And later on, now you have all of the metrics available. Now you can split the usage by subscription ID, by this cost center, and basically understand how many tokens were consumed by each application, each team, so that later on you can do cross charges respectively. Another thing, as I mentioned, like PTU versus pay-as-you-go is important. We had load balancer circuit breaker in Azure API Management for a while, but then we only had like a basic round-robin mechanism to load balance between multiple endpoints, which doesn't make a lot of sense in PTU scenario. It makes sense when you have multiple OpenAI endpoints and you would just want to distribute traffic, but not in PTU. So what we did is we introduced priority-based load balancing. So now you can say that I want to exhaust my PTU quota first before failing over to pay-as-you-go endpoint. And this is something that you can configure in the backend section APIM that I will show you in a couple of minutes. Another thing is authentication authorization. I mentioned that you probably don't want to share one single key with everyone with no option to rotate it or revoke. What you can do instead with Azure API Management, you can configure managed identity authentication from Azure API Management to Azure OpenAI. So in that case, you don't need to share or even store this key, this OpenAI key anymore. And on the API consumer side, they can use subscription keys provided by Azure API Management, which can be easily revoked, easily rotated, and so on. If that's not secure enough, you can go even further and you can actually validate JOT tokens in APIM to make sure that you can provide more granular access to your API consumers based on the claims in the JOT token. Another thing is Azure OpenAI token limit policy. As I mentioned, like tokens, they cost money and they are pretty expensive. And you want to make sure that, first of all, let's say if you're doing a hackathon, you want to make sure that a specific team does not go over the limit that you assign to it. So that's something that you can do with token quota. For example, you can assign it per day, per hour, per week, per month, per year to make sure that your costs are under control. And another thing is if you have multiple teams calling the same OpenAI endpoint, you want to eliminate the noisy neighbor problem where one team can consume all of the tokens, all of the quotas from the endpoint, leaving other teams with no option to call the LLM. So that's something that you can do with tokens per minute assigned per your team, which can be, again, subscription key, can be IP address, can be header, can be pretty much anything else. And another thing is semantic caching policy. In the API management world, caching is pretty common. Like you cache requests, you cache responses for frequent requests. Here we implemented something similar, but with AI flavor to it, because what you want to do instead here, instead of like just comparing requests, essentially, instead of comparing requests, you want to compare prompts in the request. And these prompts can be different, but they can semantically can have a semantically similar meaning. So what we did is we introduced integration with Redis in Azure OpenAI embeddings model. So for each prompt which comes to APIM, we can now calculate the vector for this prompt. And then for all of the following prompts, we can compare how similar those two prompts are based on the vector distance. And then if we realize that they're similar, we can actually return completion from the cache, from Redis cache, instead of hitting the OpenAI backend. So in that case, you not only save a lot on latency because completions take time to be generated, but at the same time, you also save on cost when it comes to token consumption. And the last thing that I wanted to share before the demo is that initially we focused on Azure OpenAI because Azure OpenAI is Azure service. We see a lot of traction with Azure OpenAI, but we realized that we want to support more models. And recently we announced the support for Azure AI Model Inference API. This is essentially an API which is a single API for multiple models, which you can deploy from Azure AI Model Studio catalog. So whether it's like a Mistral, Cohere, our own models such as 5.3, 5.4, Llama, all of these models, they provide a single inference API, which can be also onboarded with API management. And you can also apply all of the policies that I showed to you previously to this API as well, which extends the number of models and the model providers that we support in Azure API management. So now let me switch over to demo. So here I'm in the Azure portal. Let me just make sure that you can see everything. So let's imagine the following situation. Like I am an AI platform engineer, and I really want to onboard one of the OpenAI endpoints to APIM to make sure that I have control and I can apply all of these nice policies that I showed you and basically benefit from controlling and governing this API. Traditionally, I can do that with I can grab the OpenAPI description from OpenAI with a specific version. I can onboard this as an OpenAPI API to APIM. Then probably I would need something like, I need to understand all of the policies that I showed previously on the previous slide. So I would go to the documentation. I will read like how to apply them. I need to understand how they work in APIM, like deal with all of this XML. So we actually wanted to like avoid this, and that's why we introduced this create from Azure resource. It now supports Azure OpenAI service. So as a person who is not that familiar with APIM, I can just simply click here. And this will give me a list of existing OpenAI endpoints that are available for me. So I know that I need to onboard this one. I can select an OpenAI API version. So we support preview and we support 3 latest stable versions. I can give it a name. So let's call it AI London. And here, this one is actually important. So we have this checkbox, improve SDK compatibility. So when your developers interact with OpenAI, they typically use some sort of an SDK. They use Azure OpenAI SDK. They can use LangChain, LangGraph, PromptFlow, and all of the other tools out there. And because the structure of an endpoint of OpenAI is has a specific, OpenAI endpoint has a specific structure to it. All of the SDKs, they expect certain parameters. For example, we know that Azure OpenAI endpoint, it always ends with /OpenAI. So we have the name of the endpoint, you have /OpenAI, you have /deployment name, and so on. So what we did is we basically appended this OpenAI to make sure that all of the SDKs that your developers use, they still work. We also know that API key is usually provided in API key header instead of the header that we use in APIM. So we also changed that with this checkbox. So in short, that means that instead of using OpenAI endpoint, you can now, once you onboard this API, you can share this new APIM, Azure API Management endpoint, with your developers. You can share the subscription key instead of OpenAI key with them. And that's it. They don't really need to change anything else. Everything that they already developed should work seamlessly. All right, and here is where the one of the best parts of this create experience. So I want to manage token consumption. As I mentioned, there is a policy for that. I don't really want to deal with policy. I want to have a nice UI, at least just to try it out and see how it works. So here in managing token consumption, what I can apply is I have 2 separate things. I have tokens per minute. So let's do 500 for now, just for the demo purposes, just for me to understand that everything works. And then for token quota, let's do like something very big because we don't really care at this point. And then limit by is here we provide a couple of properties which are pre-built, which is subscription and IP address. Subscription is, as I mentioned, pretty traditional way to distinguish API consumers and API management. So we use subscriptions. And here, I don't really want to estimate prompt tokens. So what it does is when there is a prompt coming to APIM, we can actually estimate how many tokens will be consumed by this prompt. And if on the APIM side, we understand that even the prompt will exceed the quota, we will not send this to the backend. Instead, we will just throttle this request. I don't really care about this for now because that's just in development environment. But what's also interesting is I can probably for my developers, it will be beneficial to understand how many tokens were consumed and how many tokens are remaining. So that's something that I will share as a header. Then I can also enable tracking of token usage. So here I can select one of the application insights instances and I can add multiple dimensions. Again, let's add subscription ID to make sure that we can break down the token consumption by subscription ID. And then here I can also enable semantic caching. So here I need to select existing OpenAI instance that has the embeddings model that will be used to calculate the vector. And then similarity scores essentially means how similar two prompts should be to be returned from cache. So it can be like less strict and like more strict, which is 1.0 is essentially almost an exact match of prompts. And then cache duration is self-explanatory. So for that, let me actually uncheck semantic caching just to keep it simple. And then on the next page, what we are saying here is that there will be a system assigned managed identity configured in API management, and we will assign this a cognitive services OpenAI user role. So this will allow APIM to call OpenAI endpoint directly without using any keys. It will use managed identity instead. So now I can create this API just for me, again, to see how all of these policies work and to make sure that that's something that I can use later on in production. So you can see like here, we created an API, we're setting up policies, and now we have this API up and running. And you see that we actually configured a bunch of policies. I don't even have to touch XML. Everything is pre-configured for me. So now just to make sure that this API works, I have this Python script that's basically, sorry, that's not the wrong one. Yeah, that's the wrong one. Let me change the API name to one that we just created. And what this does is it basically sends 10 different prompts to this endpoint that we created with just a prompt, can you tell me a story about APIM in 100 words? And as we can see from the logs, at some point we actually got throttled. And if we visualize this, we should see this graph. If you remember, we set up the 500 token limit. So once we reached 500, we allowed one request more because we did not estimate the prompts. But here you can see that all of the following requests were throttled according to the tokens per minute limit that we set up. All right, so we tested it, everything works, everything's fine. But now my team actually identified some of the use cases and they purchased the PTU endpoint. And now they want to use PTU and pay-as-you-go in the same environment. So what I can do now is, and that's actually something that I pre-configured here. So here's an OpenAI production environment. And the only difference between this and what I already created in front of you is that we have this backend, which is OpenAI LB. And if we go to the backend section, we can see that this is actually a load balancer. And in this load balancer, we can see that we have two different endpoints. So we have this PTU OpenAI endpoint, which is my PTU. And then I have this production endpoint. My PTU is located in Canada, and my production environment is located in East US. And here, instead of just sending requests evenly with round-robin algorithm, what I'm doing is I'm setting up priorities. So I'm setting priority 1 to my PTU endpoint and priority 2 to my production endpoint. Another thing that I had to configure is that my load balancer have to understand somehow what does it mean when the backend is not available. So for that, I use circuit breaker. So I configured circuit breaker for these two endpoints, which is PTU and production. So if we can take a look at the PTU endpoint and circuit breaker configuration here. So basically, for even a single request which is failing, in the 15-second interval, what I'm doing is I'm looking at the status code range. So whenever there is a status code range from 400 to 499, but we care about 429 here, because that means that we are throttled. So whenever this condition is true, we will trip the circuit for 15 seconds, which is not ideal because that's just a static value, and ideally with PTUs, I want to exhaust it at its maximum, right? So I want to make sure that when the endpoint is available, I want to hit it again. So that's why I'm enabling this retry after header, because I know that OpenAI endpoints, they return retry after header with the value after which I can retry. So I will use that instead of 15 seconds if it is available in the response. So yeah, and I did the same for the production OpenAI endpoint similar configuration. So now if I go back to my VS Code, I can run the script. So that's essentially sending, again, same requests to a different endpoint, to a different API. And here we can see that we sent first request to Canada East, then it was throttled, and APIM basically rerouted requests to East US, which is my pay-as-you-go endpoint. And then once Canada East is recovered, we should be able to see that we hit Canada East again. Yeah, apparently it looks like that the retry after was super high. That's why we don't really see that it fails over. I mean, it returns to Canada East again, but essentially that's how it works. So if you have something set up like a very low number on Canada East, then it will immediately go to East US, and then that's basically how you can route requests between multiple PTU and pay-as-you-go endpoints. You can also add multiple PTUs or multiple pay-as-you-go endpoints. You can also group them by priority. So your PTUs is priority 1, and then your pay-as-you-go is priority 2, and then there will be a round-robin algorithm in those 2 groups. So that's something that you can do with Azure API Management as well. All right, so we sent a couple of requests. So now what we can do is we can check the token consumption, right? So we configured integration with Application Insights. So here I can go to Application Insights. I can go to metrics. And here I should be able to see a custom metric that we emitted from API Management, which is completion tokens, prompt tokens, and total tokens. So if I select total tokens, we can see that, and we can also, let's see, we also need a summary, a sum of those tokens. We can see here that we consumed 11,000 tokens, which is a lot, right? So we can see that I also played a little bit before the demo. So you can see like 2,000 here, like 1.5 here, and this is like one of the spikes that was right before this hole. But what's nice about it is I can also apply splitting, right? Because we use different subscription keys. So now I can see that actually the majority of tokens that were consumed, they were consumed by application 2, and my application 1 only consumed a little bit more than 1,000. So this will give you kind of an observability on what's happening when it comes to token consumption. And then later on, I can also say that, okay, I will do cross charges to this application 2 team because they consumed the majority of the tokens. All right, so now we understand how many tokens were consumed, and I want to lower this number, right? I don't really want to have that many tokens consumed, especially the majority of them. Well, we haven't looked at this, but most likely the majority of them were consumed by completions. So what I configured here is the separate API that supports caching. And here in the VS Code, we can see how it works in action. So what I'm doing here is that I'm hitting this API that supports caching. And basically, I'm asking the same question in a different format, like what time is it from the model. And here you can see that we sent 10 requests. And if we visualize this, as expected, we see that the first request took a little bit more than 2 seconds, while other requests, for all of the following requests, were returned much faster because they were returned from cache. So we saved a lot on latency and also on the token consumption. All right. So we fixed the load balancing. Now we have production environment running. We have good understanding of token consumption. We also have semantic caching in place. But then like my team started experimenting with other models. Like we have GPT-4o, we have all of the different models, but my team started experimenting with Mistral models and Phi 3. And I want to apply similar concepts to those. So what I was doing here is I have this AI model inference API, which points to one of the endpoints for Phi 3 model. And here, just again to see how it works, to see that our policies actually work with a different model other than OpenAI, I set up a token per minute limit as 100. And now I can test this API. So I'm just using the same instance of APIM. So what I will do is I will send this request. Again, tell me a story about APIM. And here in the response, we can see that this request was served by a Phi 3 model, which is deployed to APIM. And now the following request, as expected, will be throttled because we exceeded our token limit. So yeah, that's how you can use all of the policies and all of the GenAI Gateway capabilities with Azure OpenAI models and models deployed through Azure AI Studio, Azure AI Foundry catalog. Now, if you want to learn more about API management and GenAI Gateway capabilities, so first of all, we have a separate documentation section in our documentation portal. You can find it on this AKMS link, OpenAI Docs. It describes every policy, describes the input experience, and so on. If you want to try something similar to what I showed you in VS Code with different Python notebooks, there is a very nice GenAI Gateway Labs resource. Let me actually show it to you. So this is the repo that contains a lot of different labs. So when it comes to load balancing that I showed you, token rate limiting, token metrics, semantic caching, and also other scenarios. For example, if you do vector search, you can also onboard AI search as an API to API management and use that together with LangChain. Or if you have a prompt flow integration, you can use prompt flow with API management. There is also a lab that shows you how to do that, how to do content filtering if you want to make sure that you detect harmful content in the prompt. And if you detect it, you can deny requests on APIM. So there are a lot of great labs here. And the beauty of it is that they come in the form of a Python notebook, so you can deploy everything. There's a bicep file, you can deploy it, you can try it, and then you can remove everything. And you can see how all of these policies and all of these GenAI Gateway capabilities and Azure API management work in action. So once you understand these capabilities, once you understand how to use them, we have two guides to help you get started with production environments. So one is AI Hub Gateway Landing Zone, which is essentially a set of opinionated bicep files that can help you set up overall environment for your AI Hub that includes not only API management, but also other services such as like log storage and AI search to make sure that you have a single central place to manage all of your AI APIs. And then there is a GenAI Gateway Accelerator, which is also like a set of bicep files to make sure that you can easily get started with GenAI Gateway capabilities and Azure API management in production. So yeah, that is all that I wanted to share today. Again, feel free to reach out to me on LinkedIn. I'm happy to chat if you have questions, if you have specific suggestions, or if you want to in general discuss your scenarios. And yeah, make sure to check out all of these links. They're super helpful to understand how this can be used in your environment.
Thank you. That was really good. We do have a question in the comments if you have a little time.
Sure.
So from James, we've got, you said this works well with all sorts of frameworks like LangChain, etc. Does APIM work with model serving solutions such as Databricks model serving?
Yeah, so I think there are two answers to this. Like, first of all, because Databricks is just like another API, you can onboard to APIM. Of course, APIM will work with any other API. When it comes to specific GenAI Gateway policies, so as long as the models that you use, if they expose messages API or chat completions API, which are compatible with OpenAI format, then all of the policies should work. So that's something that we're currently looking into, how we can support more models. One option, as I mentioned, was AI Inference API. But again, for example, the one demo that unfortunately I wasn't able to show today is, for example, you can use Hugging Face text generation inference product to deploy models to Kubernetes cluster. And because TGI, or text generation inference, exposes messages API compatible with OpenAI, all of the policies work. So it all comes down to the API format, honestly.
Nice. I have a couple of my own questions while we wait for some more to come through if there are any. Can you use multimodal models through APIM?
Yeah, so that's a good question. So today we support mostly text-based input. I think we already rolled out, or we are rolling out the version of GPT-4o support, for example, for images. So that means that you can use not only text, but also images with this.
Nice, very cool. And does it work with streaming as well? You can stream with Azure OpenAI, right?
Oh yeah, absolutely. So one of the key considerations we had when we started with GenAI Gateway capabilities, we wanted to make sure that all of the policies that we implement, they support streaming. So everything you saw, like token limiting, emit metric, everything works with streaming.
Thank you. Awesome. All right. Well, we haven't got any other comments, so I will let you go. Thank you very, very much for joining us.
Sure. Thank you for having me.
Thank you. Cool. So just before we wrap up, I will just throw on those links again. So again, if you would like to keep watching us, join us for either our remote or in-person sessions, please feel free to join our meetup group. That's where we make most of our announcements. And the second one is, if you're around on the 6th of March around London, we have an all-day Global AI Bootcamp where we have about 10 speakers that are coming in and delivering all sorts of Azure AI content. So with that, I will let you enjoy your evening, and thank you very much for joining.